So you may have heard the expression the exposure triangle. This refers to the three fundamental controls that our cameras have to determine how much light we receive onto the sensor to get an accurate exposure. And those three things are ISO, aperture, and shutter speed. These three variables need to be kept in balance at all time to get an accurate exposure. And when I say accurate exposure, I mean just the right amount of darks, midtones, and highlights for the scene that you're trying to record without allowing too much or too little light. So you get a good spread of information across the whole image. So if we look at all of these one by one individually and then see how they work together. So ISO controls the sensitivity of the sensor. What that means is, depending on how much light there is available, you need to have a more or less sensitive sensor. So if there's a lot of light available, like on a bright sunny day, you might wear some sunglasses or something, or just squint your eyes or shade your eyes, because the light that's flooding into your eyes is very, very bright. So your pupils actually contract, they become less sensitive, so you're not damaging your eyes. And it allows you to see accurately. Whereas if you're in a darker environment, your pupils will dilate and they'll get a lot bigger and they'll become much more sensitive, which means you can see a little bit better in the dark and the shadows. Same sort of principle applies to what ISO is doing. Now, different cameras will have different levels where they kind of have the lowest and the highest levels of ISO. But the more higher end cameras will go down to 50 as the lowest. Maybe some of the consumer cameras will start at 100 or 200 ISO. But what we're looking at here is, say, the lowest ISO sensitivity setting is 50. Now the next incremental change or ISO setting available is 100. So mathematically, we've gone from 50 to 100, which is double. So you've doubled the sensitivity, which makes the image appear brighter. It doesn't actually change the amount of light that the image has, or the amount of light that's being received onto the sensor. It just means that the sensor, because the light still is the same amount, but the sensor is just that much more sensitive to receiving that light, and therefore it appears to be brighter. The next incremental change is 200, and again you're doubling it, then 400, and so on, 800, 16, 32, and so on. Now I've shown the higher value ISOs in red because there's a bit of a problem that comes with pushing the ISO too high. It does allow you to shoot in a slightly darker environment, but it comes at a cost. We'll look at that in a second. So mathematically, we're looking at doubling or halving these values, and in photographic terms, what we call that a stop. So that's a full stop. If the maths is double or half, so from 50 to 100, 200 to 400, and so on, or going backwards, you're halving it. But most cameras, some of the sort of cheaper, more consumer cameras, may not have thirds incremental changes in between that, but most cameras will also have values in between these full stops, which are a third of a stop. The thing is, when you push your ISO too high, it does allow you to shoot in a darker environment, but it comes at a cost. And that is what's known as the digital noise, especially noticeable in the shadows. So as you increase your ISO, you'll find that you get more of this kind of coloured speckles and what have you. It doesn't look very pretty, and it's best avoided. Now, 800 is always, for me, being the sort of cutoff, or the point at which I'm starting to become aware of the ISO. I don't like going above 800, but modern cameras are really good nowadays, and you can push it a lot higher, 16, even 32 or 6400. And you don't get quite as much noise as you used to. But it's just something that you need to be aware of. So when you look at these two images, for example, they are the same exposure. If you look at the histograms, they're as near as damn it the same. If you don't know what a histogram is, don't worry about that. But when you look at the values here, the ISO on the picture on the left is at 100, the ISO on the picture on the right is at 12,800. Now, the constant here in both of these images is the aperture at f8, and the picture on the left is shot at half a second, and the picture on the right is shot at 1/250th of a second. That's resulted in the same accurate exposure. But if you look closely, especially in the shadow areas, you look at the image on the right, you can see all of that noise, the speckled colours. That's pretty ugly. The picture on the left doesn't have any of that. So that's where you just need to be aware of pushing the ISO too high. The next thing to think about is aperture. Aperture controls the intensity of the light. It's a physical opening inside the barrel of the lens. It's an iris that opens and closes. The thing that confuses people often is that the values seem to be inverse to what they're actually describing. And different lenses will have a different range of apertures available. But using a sort of classic example, if f2 is the widest aperture available, the next incremental change to make it smaller is f2.8. Now the relationship between f2 and f2.8 is exactly one full stop. What that means is that f2.8 lets in half as much light as f2. There is a reason why the numbers seem to be so confusing. I'm not going to go into that now because it's boring and unnecessary. And if you're interested, the F stands for focal ratio. Again, you don't need to know that. The next value is f4, which is again half as much light as 2.8, and so on, all the way down through to f22. Now again, some lenses will have slightly different parameters. Some lenses will open up beyond f2 to 1.8, 1.4, 1.2, and so on, and some lenses will stop down smaller than f22 to f36 or whatever. But again, the relationship between these values is one full stop. So you're either doubling or halving the amount of light that you can receive onto the sensor. But again, cameras nowadays have thirds of a stop values in between these. So it gives you a little bit more control in terms of making adjustments to get accurate exposures. Incidentally, all of these full stop incremental changes, either with ISO, aperture or shutter speed, it's always just one click on the dial on your camera that will make a change of a third of a stop. So to change from f2 to f2.8, the dial that you're operating to make that change, it will be 3 clicks. So it's something that after a little while of playing around with that, you'll get familiar with that kind of muscle memory. So the next thing to think about is shutter speed. Shutter speed is measured in fractions of a second. The two little ditto marks is the international symbol for seconds. So if you see that little mark next to a number, the number before it is seconds. Now, most cameras will have a setting called bulb. Bulb is basically where you press your finger on the shutter release button, and as long as you hold your finger on the button, the shutter will open and remain open. So you can be there for a minute, 2 minutes, 3 minutes, 5 minutes, however long you want. Something that you're not ever really likely to use. It's useful for things like lightning strikes or fireworks or something like that. But you've got then the built-in times: 30 seconds, 15 seconds, 8 seconds, 4, 2 and 1. Now the relationship between these again is a full stop. Half of 30 seconds is 15. Now half of 15 is actually 7.5. But what's half of 7.5? And what's half of that? Doesn't take long before you're in trouble. So instead of being 7.5, it's 8. 8 seconds, 4, 2, 1 seconds. These are all shown in red because they're very slow. Photographically, this is very, very slow. Once the two little ditto marks disappear, you're looking at fractions. Some cameras will show it to you as a fraction, 1 over whatever number that is. Some cameras in the viewfinder will only have the number. So for half a second, you'll only see the number 2. But for 2 seconds, you'll see the number 2 with the little ditto marks. So we're looking at fractions of a second now. Half a second, quarter of a second, 1/8 of a second. And again, instead of being 1/16, mathematically it's easier when it's 1/15 of a second, 1/30th, 1/60th. Does a funny little thing again from 1/60th to 125th, all the way up to 1/4000th. Some cameras go even beyond that. And what you need to understand is that that's 1 second split into, for example, 4,000. It's the tiniest, minutest little fraction of time. And that's the amount of time that the shutter actually opens for to allow light to pass through and hit the sensor. So what you need to think about is that, let's say for the sake of argument, 1/4000th of a second, the shutter is open for such a small amount of time, you're not going to get enough light to have an accurate exposure. But on the other side, if you open up the shutter for, say, 1 second or 2 seconds or 8 or 30 seconds, that's a crazy long amount of time, and you'll get so much light coming into the shutter that you'll get probably an overexposed image. But again, think about the maths of these numbers each one of these incremental changes is a full stop. You're either doubling or halving the amount of light that you can receive. Now, in between these full stops, similarly with the ISO and with the apertures, you'll find thirds of a stop, incremental changes. So for the sake of argument, between 1/30th and 1/60th, you'll find 1/40th and 1/50th of a second. Between 1/60th and 125th, you'll find 1/80th and 1/100th of a second. These numbers might be a bit confusing at first, but play around with it, you'll get familiar with them. You'll find that in the majority, and there's by no means absolute, but the majority of photos you take will probably fall within this kind of range, from 1/15th of a second to 1/250th of a second. But the reason I've shown all of those other numbers in red is that they are slow shutter speeds. So as a general rule of thumb, oops, I've just gone back, you need to think that anything roughly from 1/60th of a second or slower will cause camera shake. So just bear that in mind. Sorry, just going through that one again. So the correct combination of aperture and shutter speed will give you a correct exposure where the ISO is constant. Obviously, if you start changing the ISO, that has an impact. The ISO can be seen as your get out of jail card. If you find that you need to use a faster shutter speed in order to get an accurate exposure, or if you're to get an accurate exposure, your shutter speed is too slow, you would want to use a faster shutter speed in order to avoid camera shake. That's when ISO can help get you out of that little situation. By increasing the ISO sensitivity, it allows you to shoot at a faster shutter speed. So the question is then, how do you know when you've got this combination correct? Well, that's where the camera has a built-in light meter. If you're not used to shooting in manual mode, you'll not have noticed this before. It will either not be there or it won't be moving and changing all the time. But as soon as the camera is switched on, the built-in light meter is assessing the amount of light that is falling onto the sensor, and it's telling you if the combination of aperture, shutter speed and ISO is accurate in order to give you the right spread of light within the image. So Canon and Nikon are obviously the big manufacturers, but shutter light meters in all camera manufacturers, they all work along the same way. So you've got a little scale. Sometimes it's a plus and minus, the minus on the left and the plus on the right. Sometimes it could be the minus on the right and the plus on the left. It can change, so don't worry too much about that. But basically what you've got is a little sort of scale, normally showing you 3 stops either side of accurate, where 0 is accurate and anything on the minus side shows underexposure, i.e. not enough light, and anything on the plus side means overexposure, i.e. too much light. And then you'll find that there's a little indicator mark that when that aligns at the middle at 0, you've got an accurate exposure. Now, underexposure will tell you that that there's not enough light coming onto the sensor and the image is going to be too dark. For a Nikon and a Canon, it works slightly differently. Nikon shows a series of little lines, and if it goes beyond the scale of 3 stops either side of accurate, Nikon will show you a little arrow that says you are off the scale. So in this instance here, you've got the large lines and then the little dots in between. The large lines show you a full stop and the little dots are a third. So in this instance here on the top on the left of the Nikon, it shows you it's more than 3 stops underexposed. The Canon will go on just one little line like that and just rest on the point where it tells you. So in this instance, it's showing you 1 1/3 stop underexposure. And on the other side, if you allow too much light into the camera, you'll have on the Canon, it will start flashing like it did there to tell you it's overexposed off the scale there beyond 3. And with the Nikon, it will stop at a point where it tells you how much overexposure you've got there. So in this instance, it's two full stops and 2/3 of a stop. So that's basically the principles of exposure. So in order to get a consistent exposure, if for the sake of argument the light meter aligns at 0 when you've dialed in an aperture of f8 and shutter speed of 125th of a second, if you open up the aperture by 1 full stop to say 5.6, in order to have the same consistent exposure, you're going to have to adjust the shutter speed. Now from f8 to 5.6, you've gained one stop of light, meaning it's twice as bright. So in order to have the same consistent exposure, the shutter speed has to allow half as much light in, which means it has to be twice as fast. So from f8 at 125th of a second will give you the same exposure at f5.6 at 1/250th of a second. You've kept those in balance. By making a change to one side, you've had to balance it on the other side. Now if you go in the other direction, let's say you go to 1/60th of a second, now from 125th to 1/60th you're allowing twice as much light in, which means that you need to balance that by allowing half as much light in with the aperture. So from f8 at 125th of a second would give you the same exposure then as 1/60th of a second with an aperture of f11, and so on with all the different combinations. This is a simple and basic introduction. I hope it's helped. If you're interested, click on the Get in Touch button, get in touch, and we can always do a one-to-one or come and join me on a little group session. And most of all, enjoy the photography. Thanks for watching.